my submission for Lab 2, Charge Tape Revisited. So, as an introduction, the objective is to observe and analyze a system of two charged tapes and then obtain data for that system so that one, we can calculate the effective gravity on each piece of tape, and then using this in GlowScript, model the tape as a line of charge, and using this model, we can guess the charge on each piece of tape. And we will also calculate the charge on each piece of tape as if they were a rod and a point charge to compare. The main ideas of this lab are basically electric force and electric field. Electric field, there are two different equations, one for point charge and one for a rod, which are shown on the left. And electric force is basically the electric field times the charge. Now, the main important part is that if two objects have the same charge, the force will be positive / a repelling force. And if they have opposite charges, the force will be negative. It'll be attracting force. And we'll see the repelling force in this lab. So as a brief preview before we get into the lab, the model predicted the charge on each piece of tape to be 3.07 times 10 to the negative 8th coulombs, whereas the calculations treating it as a rod predicted it to be 2.41 times 10 to the negative 8th coulombs, which is less than that. And treating it as a point charge, it was 3.76 times 10 to the negative 8th coulombs, which is more than that. And the system was the top tape, whereas the surrounding was the bottom tape, the earth, the erasers, table, everything, as you can see on the right. So what models will we be using? So the models we're using are Newton's second law and electric field on a rod and point charge. So we find the distance between the floating tape and the regular one, as well as the mass, in order to find the force due to gravity, using that to find the electric force and using that to find the charge. Now we'll do that twice, one for a line charge and one for a rod. And so specifically for a rod and the line charge, we assume no air resistance or friction, the origins at the initial position of the regular tape. Each tape has the same mass, length, charge being evenly spread across the tape, and each tape is treated as a rod, which is similar shape as the tape and easy to calculate, and kind of the same for the point charge one, but that's more in the GlowScript code. And these assumptions are made for ease of calculation. And the equations are below, and the initial values are on the right, specifically the density, length, mass, separation distance, and constants. Getting into the experiment. So same as last time, this shows one tape floating above the other, attached to two erasers and a ruler, and it just shows one tape repelling the other, and this is the observation that we modeled the model and the computations off of. So now we take our data and make calculations. We start off by calculating the force due to gravity, and once knowing that, because of the observed values, we know that it is equal to the electric force, opposite and equal, because the sum of forces must equal 0 because it's in equilibrium. So after that, we know the electric force, and the electric force is Q times E, and since both tapes have the same charge, we can use the electric force equation of a rod and rearrange it to find Q. And plugging everything we get Q of 2.41 times 10 to the negative 8th coulombs when modeling the tape as a rod. So for the code, the highlighted stuff is the important part. So first, the Q we found by guessing and checking. We set up the rest of the code first and then guess the Q until it matched gravity to see what the model would predict. So second is the function for the electric field, which was explained earlier. That's all that does. And then there's the function for modeling a line charge, which is a line of point charges. So this makes a bunch of point charges in a line. So next up on the left, we have a model of two tapes, top tape and bottom tape, which matches our observations in our experiment. And then we have the scale factors, which are basically just letting us see the arrows because they're too small. And then on the right side, we modeled the electric field and electric force for each little piece of the line charge. And then we will add them all together to get the total force and electric field from the bottom tape on the top tape. And that's what's shown on the right bottom, is just printing the magnitude of those. So this is just what happens when you run the code. You get a model of the electric force up, gravity force down, and little arrows representing each little field and force for the point charges in the line charge. So let's discuss the data. So looking at the data, the force of gravity on both pieces of tape is negative 1.27 times 10 to the negative third newtons, and the electric force on tape A due to tape B is 1.27 times 10 to the negative third newtons, so they're opposite and equal. And the charge on each piece of tape, by assuming that they are rods and taking the electric force of the rod, was 2.4 times 10 to the negative 8th coulombs, which is less than the charge of assuming they were point charges, which is 3.76 times 10 to the negative 8th coulombs, which is more then 3.07 times 10 to the negative eighth coulombs, which is guessing till the forces cancel out. So the model charge is greater than that of the calculated one, but they both agree in magnitude, meaning that they're likely good predictions. So my error could be that I didn't take into account air resistance or friction, the tapes are not rods, and the density of the tapes are not exact, and there could be rounding errors or experimental errors. So for additional questions, modeling the tape as a point charge gives us a greater charge than that of modeling it as a line charge, which is also because of the fact that they were modeled differently. The line charge is a little more precise, meaning it's probably more accurate because we looked at little bits of the tape instead of all just at once, leading to an overestimate for the point charge.